Hello and welcome to this video, which is all about mental addition and subtraction with large and decimal numbers. In this video, I'm going to talk about 6 strategies for mental addition and subtraction that give exact answers, and I'm also going to talk about how we approximate in order to create approximations to the answers to addition and subtraction questions. So if you don't need this video, here's a skip link to the next video, which is all about the images of multiplication and division that children encounter at primary school. If you find this video a little bit challenging, there is a video about teaching mental addition and subtraction to children aged 7 to 9, which covers the 6 strategies for getting exact answers to calculation through mental methods that I'm going to cover now with larger and decimal numbers. So if you'd like a slightly easier introduction to this topic, here's a link to that video now. Also, this video assumes that you are really confident and comfortable shifting between subtraction being taking away and subtraction being finding the difference between two numbers, and that you understand why both those methods work for subtraction. So if you'd like a little support and reassurance with that, here's a link to a video which covers that particular part of maths in detail. Okay, let's get started with your first mental method for addition. If you look at this calculation, 299,997 plus 365, can you do that in your head? And if so, how did you do it? Well, there are various ways to do it, but the one I'm drawing your attention to now is that you can imagine 3 from this 365 filling this number to 300,000. And then you've got 362 left to add on. So the answer is 300,362. Let's just look at that with an open number line. 299,997. What we're doing is, instead of trying to jump on 365 in one go, we're splitting it into 2 parts. We're adding 3. And that takes us to 300,000. And then saying, well, we've still got 362 left to add. Therefore, the answer is 300,362. So where one number is close to quite an easy number to imagine, it's just below it, this is a great strategy to use. And you can check this with column addition, but column addition is fiddly with these numbers because you're going to have to exchange several times. Right, let's look at your second strategy for mental addition before we move on to 4 methods for mental subtraction. So your first method was adding in 2 parts. Let's look at this calculation here. 156.82 add 2.98. Can you see a shortcut for this? Well, the strategy I'm going to suggest here is the bounce back strategy, where we're going to add on 3 and then bounce back 0.02. So this would become 159.82, and then we need to subtract 0.02 because we're not going quite as far as adding 3. So that would make the answer 159.8 or 0.80. Let's look at that with an open number line. So we're starting at 156.82, and we could try to add this in parts, but instead of doing that, we're going to add 3 to get 159.82. And then we're going to subtract 0.02, and that takes us to 159.8. And that's our answer. So this strategy is particularly useful when the number that we're adding is just less than an easy number. All these mental strategies only work for the calculations that they work for. Column addition, column subtraction, they are universal, they always work. They're brilliant methods, they're completely reliable. Mental methods, it depends on what numbers you're adding and subtracting as to which mental methods, if any, are any use. Right, let's look at your third method, which is your first strategy for mental subtraction. Consider this question, 56.02 minus 0.67. You might like to pause the video and just see if you can puzzle that out in your head and see if you can recognise how you've done it, if you can do it. I would do this using the subtraction version of the two-step method that we used for addition. So I would say 0.02, if we take that off, we get back to 56. And then we've got 0.65 left to subtract. And that I can pretty much do in my head. 56 subtract 0.65 becomes 55.35. I couldn't do that as a column subtraction in my head. Let's just look at that with a number line. So we're using subtraction as takeaway. We're starting at 56.02. And we are subtracting 0.02 to get to 56. And then we're saying we've got 0.65 left to subtract, which takes us to 55.35, which is our answer. Now, with all these methods, you want to take time to listen to children and see if they can puzzle out a strategy for themselves. A child doing this may not have been able to do this subtraction in one step. They might have done it in two steps. And that's fine. You can notate their method just by showing the steps that they used. This shortcut doesn't always have to be 2 steps. It can be 3 steps. And they may have done this using one of the other strategies that I'm about to go through. So with mental calculation, it's a great idea just to set the question, set children working on it first on their own and then in pairs or small groups and feeding back to you their methods. Then as a teacher, it's your job to notate each method, to bring it to life, to make it communicable to the rest of the class so that everyone can examine everyone else's methods. Much easier if you're working one-to-one with a child, if you're a parent or a tutor. So with that in mind, mental method number 4, which is your second for subtraction. 2,846 subtract 198. Pause the video if you need to and see if you can puzzle out your way of doing that. The method I want to draw your attention to now is the bounce back method, which we used for addition. Now we're going to use it for subtraction. This is still subtraction as takeaway. So we start with 2,846, and instead of trying to subtract 198, we subtract 200, which takes us to 2,646. Now we've subtracted too much, so we need to add 2 back on. So we add 2, and that's easy to do, 2,648. Hopefully, whichever method you used, you got this answer. And if you don't know how to notate your method yet, hopefully it's going to be in one of the last 2 methods that I'm going to show you now. If not, please do describe it in the comments to this video because I'd be fascinated to know. Okay, I'm going to use this example for our final 2 methods. 1,572.03 subtract 1,571.98. Can you do that? If so, how did you do it? Well, it's horrendously difficult as a column subtraction. but it's easy when you see subtraction as difference, because these numbers are so close together. And quite quickly you can see that the answer is 0.05 because that's how far apart they are. Let's notate that with a number line. As always with open number line, the only rule is that higher numbers go to the right. This is our larger number, so 1572.03. If we were doing subtraction as taking away, we'd be trying to remove that amount and move backwards on the number line by that amount, but we're not. We're looking at subtraction as difference, so we just place this number on the number line. It doesn't matter how far apart they are, 1571.98, and then we're just trying to find the difference between the two. So it's helpful to put in the number 1572, and then we can see that that is 0.03 and that is 0.02. Therefore, the answer is 0.05. So it's always useful to bear in mind your differences and look to see if that makes the calculation easy to do in your head. The final method I'm going to show you is shifting the difference. When you're using differencing, you don't have to use your original numbers. If you add or subtract the same amount to both of them, these numbers stay the same distance apart, so your answer stays correct. So what I'm suggesting you can do here is add 0.02 to both numbers. So if you do that, the calculation becomes 1572.05 subtract 1572. 1572.05 subtract 1572. And all we've done is move the difference 0.02 that way. And now that is easy. That's clearly just 0.05. So there you have 6 mental addition and subtraction strategies that will give you perfect answers in some situations, and they're strategies that should be part of you and your students' repertoires. The other side of this that becomes really relevant at this age is doing approximate calculations by rounding the numbers. So if we consider a calculation like this, 17,984,152, add 6,280,971. Well, two things are becoming evident here. The first is that the vast majority of people cannot do calculations like that in their head. They'd need to set that calculation up carefully and it would take a long time. The other thing that's becoming obvious is that the smaller digits are much less relevant in understanding your answer. So it's really reasonable to talk about this calculation being approximately 18 million, add 6 million, and to talk about the answer as being about 24 million. And similarly, if this was a subtraction, we could talk about 18 million, subtract 6 million approximately, and the answer being about 12 million. Now, we're not being strict about where to round off or what level of rounding is appropriate. We're using our common sense and thinking about what degree of accuracy seems relevant to the situation. Do we actually need all the detail? If so, then we're going to have to do a column calculation. And what can we actually manage in our heads in terms of the level of detail that we take into account in the question? The best teaching at this level involves teachers always challenging children to find an approximate answer to their calculation before they work it out in detail. So they always have a sense of the size of their answer, and they're always sense checking that answer to check that it is approximately what they expected it to be. So it's great practice for quite a while to set children a calculation with large numbers or decimal numbers with lots of detail, or maybe both, and to get them to estimate their answer and then calculate their answer exactly. And you can do one of those at the beginning of each lesson if you're a teacher, and you can get children to share their strategies and their thinking. or at the beginning of each session if you're a parent or a tutor. And you can really get children to become articulate and to describe their own thinking and to develop their own thinking as you go. And if you can embed the idea that when children are doing any question, they should always develop a sense of the size of the answer before they work that answer out in detail, then you're doing a great job. Well done. I'm not going to suggest extension work for this topic because what I've actually described already in it is so challenging. I want to take time to acknowledge that most teachers and tutors won't cover all those strategies, and most children won't get to practice them extensively and get them really thoroughly embedded. So your extension work is really just doing more on it. Sometimes children will extend you by coming up with strategies that you hadn't thought of. That's something that I love as a teacher and a tutor. But if it phases you at all, please just capture what they're saying, share it in the questions and comments here, and get whatever support you need to build your confidence and to deeply understand what they're doing. The other extension activity for children is that in working on this topic, they should become really articulate in describing their own thinking. And if you can get them to work with other children to help other children describe and develop their thinking, and get your child who's flying to tune into the thinking of children who see the world differently to how they see it, that's great extension and challenge work for those children. It's really developing both their foundations of maths and their human skills as mathematicians at the same time. So your takeaways from this video are that children should now be developing 6 strategies for exact mental addition and subtraction and applying those strategies to large numbers and to decimal numbers. And children should also be learning to carry out approximate calculations, and they should be using that skill to have a sense of what their answer is going to be with a detailed calculation and to sense check their answer. That's it for this video. If you have any questions, please write them in the comments. If you liked it, please share it with your friends. If you've not subscribed to the channel yet, please subscribe. Maybe give us a like on the video, it's hugely appreciated. And I hope you'll join me for the next video, which is going to be all about the different images of multiplication and division that children encounter at primary school. Thank you for your passion for teaching and educating the children that you're working with. The world needs people like you who care enough to understand all these things in tremendous depth. Hope you have the great day that you deserve. Bye for now.